Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Kinetics in Nanostructured Materials from Unit 4 Nanostructures and Characterization Techniques. On completion, the students will be able to understand the kinetic behavior of nanostructured materials, list out the key factors affecting kinetics in nanomaterials, and also understand the applications of kinetics in nanostructured materials. Kinetics in nanostructured materials. The nanostructured materials are materials that are having structural features in the nanometer scale, that is in the range of 1 to 100 nanometer, and their kinetic behavior differs significantly from the bulk sized materials due to the presence of higher surface to volume ratio and quantum effects. Kinetics refers to the rates of processes such as diffusion, phase transformations, and also chemical reactions in these materials. Key factors affecting the kinetics in nanomaterials. They are high surface area, grain boundaries, quantum size effects, defects, and interfaces. High surface area. The larger the surface area, it accelerates the surface driven reactions and diffusions in the material. Grain boundaries. The nanomaterials have numerous grain boundaries that act as fast diffusion paths. Quantum size effects. Electron and phonon behavior changes affecting the thermal and electrical transport in the material. Defects and interfaces. Increased defect density will influence reaction and diffusion kinetics. Diffusion kinetics. Enhanced diffusion. Atoms diffuse faster along the grain boundaries and surfaces in the nanomaterials, and the diffusion coefficient will get increased because of shorter diffusion paths as well as more grain boundary volume fraction, and the diffusion coefficient can be given as d is equal to d naught exponential of minus q by rt, where q is the activation energy, which tends to be lower in the case of nanomaterials. Phase transformation kinetics. The nanomaterials show faster phase transformations due to lower nucleation barriers and also increased surface energy contributions. Nanostructuring can shift transformation temperatures and mechanisms, and lower activation energy for transformation and suppression or stabilization of metastable process spaces also can be the reason for the temperature and mechanism transformation. Example, faster crystallization occurring in amorphous nanomaterials. Reaction kinetics, catalytic reactions. Example, carbon CO oxidation, hydrogen evolution are often enhanced in nanomaterials because of as they have more active sites and also higher reactivity of the surface atoms. Nanoparticles often show enhanced chemical reactivity due to high surface area and more unsaturated atoms at the surface. Grain growth and sintering. Nanomaterials are thermodynamically unstable due to their higher surface area. And kinetically, grain growth and sintering are driven by the reduction of surface energy. But grain growth is often slower at lower temperatures in nanostructured systems due to xenopinning by fine particles or interfaces. Electrochemical kinetics. In batteries and supercapacitors, nanostructures exhibit ion transport rates, charge discharge kinetics, and life cycle. Nanostructures, electrodes, show faster lithium or sodium ion diffusion and higher current response. Applications of kinetics in nanostructured materials. In the area of catalysis, the importance of kinetics is that it has fast surface reactions and turnover frequency. Battery material. The importance of kinetics in battery materials is that as fast charge or discharge as well as ion mobility, sintering of nanopowders. They have controlled densification without grain growth, hydrogen storage, quick absorption and desorption of hydrogen, drug delivery, control release rates from nanocarriers. Quiz questions on kinetics in nanomaterials, nanostructured materials. Explain the kinetic behavior of nanostructured materials. What are the key factors affecting kinetics in nanomaterials? What do you mean by phase transformation kinetics? Write about reaction kinetics. Write down the applications of kinetics in nanostructured materials. Thank you.